Hi everyone, I'm Baha. I'm currently a freshman at Columbia University. I'm double majoring in math and physics, and I'll be joining you guys at these online classes that are organized by Twing. We'll be teaching you coding and some other really fun science stuff.
So, hello everyone, welcome to this first session of Exploring and Learning at Home with Twing. My name is Ekin, and I'm currently a 12th grader in Bahçeşehir High School for Science and Technology. And I was admitted to Northwestern University like 4 months ago, and I will be studying material science and engineering there with a minor in history. So, I've been working in Twing for almost 3 months now in the content department, but I'm also one of the few people who adds new challenges, shoots countless videos for the mobile app Twing, which we will check it out together today. I'm especially interested in robotics and space, so let me know if you like robots and nebulas too. As you know, new precautions are taken every day to prevent coronavirus from spreading all around the world, and schools are dismissed due to these new health measures. As a result, we will now have to spend a little more time in our homes. So we will be there for you every weekday at this time. And with every topic we'll cover, we will try to learn the science behind these somewhat magical tricks and explore fun ways to do them. And just a reminder before we begin, be sure to download the Twing mobile app. We also need your help to improve this session. So don't forget to send us messages and emails about your suggestions and comments. Now, we may go through difficult times. However, I always remind myself that we are not the first. In fact, there have been such times when people panicked and fell down due to some dramatic changes throughout history. Instead of worrying, we should focus on improving our knowledge and use our time effectively to solve these problems. Graham Bell, for instance, he was one of my role models regarding this issue. Unfortunately, but fortunately for the humankind, his mother and his wife were deaf. Instead of complaining, even giving up his studies, he worked hard to figure out a solution for this problem and solve the hearing impairment once and for all. And during his studies, he invented the telephone, then began his journey to become rich and famous. However, he never forgot his main goal. In one of the letters he sent to his wife, he told her no matter how rich or famous he might become, he would always use all of his money and time to solve this problem. Afterwards, he made dozens of inventions that we are still using today. As a matter of fact, it is one of his inventions that allows us to broadcast this session on the internet. He found out that data could be transmitted by light, which is now known as the working principle of fiber optic cables. This story of Graham Bell reminds me a quote from Anatolian's most important philosopher, Yunus Emre. I have not come here to get revenge and fight. I've come here to give love and delight. Yunus Emre said those words during a wartime in Anatolia. And just like he said, we should try to solve real life problems by caring for ourselves, the others, and the nature. These are good sources of inspiration for myself. And now it is time to share our knowledge with love and discover the science in our daily life. Now, everyone, if you are ready, the first episode of Explore and Learn at Home with Twing begins. Today, we're going to take a few steps to the magical world of computers and coding, and Baha will guide us through there. So, if Baha, would you like to
I think
start?
we are experiencing some, I think, technical difficulties with the internet connection. I couldn't hear what you just said. Could you please repeat that for me?
Yeah, I just said, Baha, if you'd like to start the session.
Yes, of course. So to start our session, we'll first go to a website that you can use not only during these live streams, but at home when you want to try to experience coding on your own. And that website is the one that you see on the screen right now, code.twinscience.com. And when you first go on there, you'll see this blank sheet with these blocks on the left and these really cute image on there, right? And this will be your main place where you can spend some time on your own, try some new ideas, and experience coding. So today we will start with what can be considered the basic principle of computers and of many different aspects, and that is inputs and outputs. Again, do you have any idea what inputs and outputs are?
Inputs like the keys we press on our keyboard when we're typing a text.
That's a really nice thing of looking at it. That's a really good example from your daily life. Pressing a button on your keyboard is an input, and the image that you see on the screen is the output that the computer gives you. Um, well, the words in and out sort of give us a hint to what they mean. Consider a computer like a box. You put something in, and then you take something out. What you put in is the input. This can be anything. This can be me talking to my computer right now. This can be a button on the keyboard. It can be anything. And the outputs also come in different shapes, sizes, forms. The sound that your computer produces is an output, the image that it produces. Um, so we have these distinct places where we see how the computer works. So one of them is the input that we just mentioned. Some of the tools that we use for this input are your keyboard, your mouse, a camera, or a microphone. And then we have two other steps that this data can go through before the output is produced. One of them is storage. Sometimes we want to save something. For example, YouTube is currently saving this video that you're watching right now so that people can watch it afterwards. My input of speaking into this camera is being stored by YouTube. We also have what's called a process, and this, which is done by the processor. The computer takes in what you give to it and then does certain mathematical operations to it. And that allows it to produce the output that you want to see. It's not quite raw data. The computer analyzes it, and therefore it produces what you specifically want from it. And then we get the output. These can be the letters that you see on your screen. These can be the image that you see on a VR headset. It can also be the sound that it produces, or if we're talking about a robot, its movement is an output. What you also see on here are some ones and zeros. You'll often see these ones and zeros with computer-related stuff. And there is a specific reason for that, why they're ones and zeros instead of any other two numbers or any other two symbols.
Well, hang on, Baha. I have a question for you before you go any further. So let's say you're calling me on my phone, and when I receive this call, is it an output? And when I begin to answer it, it's like an input, right?
Well, inputs and outputs can be considered specifically case by case. What I do as an input might be an output to a different system. For example, me speaking is technically an output of me as a person, but that's also the input of the phone. So me speaking into the phone is my input, and it's something that your phone outputs. Your answer to your phone is your input, and what I hear from my end will be the output from my phone.
Now I see. All right. And what about these ones and zeros?
So all the data that a computer analyzes is actually made up of ones and zeros. That's because our computers don't speak a language. They don't know English, they don't know any other language that we can communicate with. The main way that they communicate with each other and do these operations by themselves is through these ones and zeros. And these represent a very principal idea in computing and even electronics. And that's open and closed. It's really that simple. A zero means that there is no signal, and a one means that there is an electrical signal. These tiny electrical circuits in your computer turn on and off to give these ones and zeros to each other. And that's the way that all of these ideas, all of everything that you see on your computer is transmitted. My camera records me speaking to you and turns it into ones and zeros, and then sends it to you, your computer, which also takes this and turns it back to this video and the audio that's associated with it. So everything that your computer does behind the scenes is made up of these ones and zeros.
But hang on, are we going to write ones and zeros all of the time to learn coding?
that's a really interesting question. And something very similar to that was what people did back in the day when they first started programming. As you may have heard, when we are programming a computer, we use these things called programming languages. Do you know any programming languages, Iken?
I guess I know a bit of Python and
Mm-hmm.
also JavaScript, where you
Mm-hmm.
draw shapes and figures and move them around. So I have a bit experience with those, but I'm not sure what we're going to do today.
Yeah, Python, Java, JavaScript, C might be some languages that you've heard. If you haven't heard of them, that's okay. We'll talk about them. We have the time to discuss all of these ideas. But what's really important about the languages that we just talked about is that they're really easy to read. They're really similar to human language, and that's because the computer takes them and then turns them into ones and zeros by themselves. These are considered higher level languages because they are much higher than the basic idea of this ones and zeros. It's really simple to understand and simple to write. But on the other hand, you have some lower level languages. These generally involve speaking directly to the processor, and these are much more harder to read and harder to write. A well-known example of a lower level language might be assembly, where you speak directly to the processor. But since it's so inconvenient and challenging, most people prefer not to use it and go for these higher level languages that we talked about.
Now that you're talking about the history of computers, I have a question for our guests, and you're also welcome to answer, but just wait 1 4 minutes. So, and then we'll see what our guests are thinking about. So the winner of this question will receive a 10 coding sets and will be presented to you by us. And here's my question, Baham. Who is the first computer programmer?
Okay, I will not answer that question, and let's see if people are writing their answers in the comments in our live stream. Reminder, we will be sending you a gift, and because of that, I think that you should be answering this question because it's a really nice gift that you'll receive, and it will be extremely fun to play with when we are self-isolating during this time period.
And just a reminder, we will be asking these questions like many times during a session. So be sure to listen us carefully and take your notes.
And just to clarify, we're not only giving this reward to the first person that answered this question. If someone already has answered it, go ahead, put your own answer in. We'll do a raffle and pick one randomly. So as long as your answer is correct, you have a chance of winning this gift.
And the clock starts now.
Okay, so as you're maybe thinking of what the answer might be, doing a little bit of research, we will do something else in the meantime while you keep on explaining this stuff. So I just told you how the computer takes in everything and turns it into these ones and zeros. So now we see one example of this. When I press the button B, my computer turns it into this string of numbers 0, 1, 0, 0, 0, 0, 1, 0. And there is a specific reasoning behind this. And the way that these are converted between each other is through what's called the binary system. Have you ever heard of the word binary before, Ikin?
Binary, it sounds like bi stands for the two, and binary is like a language that consists of two characters only.
Well, that's one way of looking at it, yes. The binary system is a way of representing numbers. So in our daily life, we use what's called the decimal system when we're talking about numbers. For example, when I say the number 19, that's written as 1 and 9. And the 1 stands for 10, and the 9 is in the units digit. So it's 10 plus 9. If I say 105, then the 1 that I write down stands for 100 because it's in the second place from the beginning.
So decimal system is like basis of 10 number. Right.
Yeah, so since we use the base of 10, the highest digit that we can write is 9. When we want to write the number 10, then we need another digit to write it. And there is a really interesting reason to why we use 10 as our base. And that's because we have 10 fingers. Since we have 10 fingers, it's really easy to count out to 10, which is why our language and our way of communication has shaped the way that it has. So if we only had 2 fingers, then we probably would be using binary, which these computers are using.
Well,
So
I guess computers don't have any fingers, but as you said, they're using the binary system because of receiving a single or not, and it depends on that, right?
yes, exactly. So when we input the letter B, it transforms it into these ones and zeros, which correspond to a certain number, which the computer interprets to be the letter B. And after that, these ones and zeros are transmitted. They are either sent to the processor, they're stored, and they produce an output at the end. And the output works in reverse. When it receives this 0, 1, 0, 0, 0, 0, 0, 1, 0, it knows to turn it back to B so that the person on the receiving end doesn't see these zeros and ones, and instead they see they see the letter B.
Hmm. Now I see, but how does the storage work during this transition?
Well, the computer basically stores these ones and zeros to use it again later if it's needed. And the computer always stores these in some capacity, even if the output is produced almost simultaneously. Um, but today we'll be focusing on something more interesting than this. This was maybe a bit too abstract for you. This what we've done so far is basically like a lesson that you listened to, but now you will do something here. Now we will go back to the website that you opened. So let me just share my screen to show that website to you.
So while Baha is opening this new tab for us to code our own programs, I'll be back to this question I asked before about our price question. So I'm not sure if any of the guys you answered, but the answer was Ada Lovelace, and she is the first computer programmer. But aside from that, the first computer ever taught was by Charles Babbage. So here's an interesting story behind it. Charles Babbage was the first to introduce a computer, but he did it on a paper. So it was like one of his scientific papers. And when he introduced this new computer, Ada Lovelace was astounded by his idea. And then she began drafting a new paper to explain all of the functions that the humans could do with this computer, with this machine. And then she became the first woman programmer. Yes,
Okay,
Bob, we're back to you.
okay. So now we're at code.twinscience.com, and we have all of these different blocks on the left. So let's look at these yellow ones. One of these is when clicked, and we see this green flag. And the other yellow one we see is when space key pressed. We can change this to be any key on the keyboard as we want. Akin, do you think these blocks represent inputs or outputs?
That's a tough one, Baham. I think it should be an input because when I press the uh, key, space key, and then the program interprets it. Am I
Yes,
right?
exactly. The
Yeah.
input is, yes, these are the inputs that we can give to our computer to tell it to do what we want. And we also have these other stuff that we can see on. For example, For example, if you connect this to your Twing coding kit, you can turn the lights on and on or off or change their colors. This is an example of an output. Let's look at something else. We can play a sound when we press on things that we can do to affect what our computer does. So we'll start off with doing something really simple. And that is that we will, for example, switch the costume. So this is our little friend, Twing, right here. And we will cause him to change when I press this button. Are you ready?
Yes, well.
Okay, let's try. So when we press this button, the image on the right changed. So we can try this with different types of input. For example, we can maybe change it back to costume one by pressing the space key instead of clicking the green button. So now when I press my space key, it turns back to the first image. And we have all of these different cool stuff that we can try. For example, let's have it speak. So something common that is done in programming is the phrase "hello world." It's sort of a good practice for a programmer to make the system output the phrase "hello world" as the first program. So we will make our sprite do that. When I press any button, it will say "hello world." Let's try. So as you can see, it says "hello world" right there, which allows us to know that it works. So let's maybe have it say something else. Again, what would you want our friend right here to say?
Let's give a big welcome to our guests. So we make him say hello to the nurse.
Okay, let's try. Yeah, as you can see, the image that the text we had before disappeared and the new one appeared. And since we said that it should show for 2 seconds, that's how long it appears on screen. We can change this to be maybe 5 seconds so that it stays on there longer. Or we can decrease it to be only 1 second so that it just appears and disappears. We have all of these other stuff that we have all of these other cool stuff that we will touch on later in our lessons. For example, the control part where we see loops or the variables. So if you want to learn more about them, you can stay tuned and look at our other lessons and watch them.
So Baha, I have a question for you. What are the other outputs we can explore in this session?
So we've been going on for some time now. So if you're at home, you can share your different questions that you have.
Baha, while we wait for others' questions, I have one for you.
So, yes.
So what are the other outputs we can explore in this website?
That's a really nice question. So one of my favorites is So one of my favorites is sound. So for example, we can maybe create an instrument of our own. What we can do is maybe have it play a sound. For example, we can make it produce the meow sound that it has by default, or you can create any sound that you want and record it here. So for example, when I press a button, it makes this meow sound. And maybe you may not have been able to hear it on the screen. You can try it at home. So we have these light and sound blocks that are really interesting, and you can play with them. We also have the looks, where you can change what happens on this little screen on the right. Or what we can do is all these motion that can be done with the Twing science kit if we connect it to it. Yes.
So
Or
what
what we can also do is maybe.
what other keys can you select, and then when any key press command?
Yeah. So we can maybe choose the right arrow and choose this block, move 10 steps. So when I press the right button, then our friend on the right actually moves towards the right. And then maybe I can do a second one where the top, the up arrow is pressed, turns. For example, when I press the up arrow, he spins around. And then when I press the right arrow, he moves by doing something like this. Something that's also a lot of fun is the random position. So let's maybe choose the spacebar. When we press space, it moves to a random position on this little screen. And we're talking about all of these interesting different keys that we can use. We have this massive list of all of these letters, all of these numbers, and these other miscellaneous keys. And it can do which key is the most. Let's maybe ask that to our listeners. If you know typing, please write that in the comments. It's a really interesting answer that I didn't expect.
So it's one of our prize questions, right?
I assume so, yes. If you get that question right, then we will be sending you a coding kit.
So, Baha,
Yes.
what else are you going to show us today?
So something else that we are going to be discussing today is on our presentation. So let's go back to it.
Yes, so as we are waiting for your questions to answer, and while Baha is working towards a new experiment with code2inscience.com, I will now introduce you to Twing. Twing is a mobile app. It's a platform which you can shoot your own versions of new experiments and share them online with your friends and families. So it's like an Instagram but for science purposes. You can think of it like that way. And it allows you to learn from each other. So achieving together is another concept both Baha and I like praise a lot. So go ahead and download the Twing app. It's free and it will let you explore a new world of science.
So if you've downloaded the app, then maybe we can go back to the website. So here's another little experiment that you can maybe do on your own. Let's get rid of these. Here. Yeah. Okay. So Something else that you can do is if you connect your Twin Science Kit to it, then we see all these other inputs that you can use. So one of these is maybe the slide dimmer or the light sensor, the sound sensor. All of these different sensors that take in some information and you can use that to produce different results. So if you're bored of pressing the keys on your keyboard, maybe you can use those kits to use the ultrasonic sensor or patience. And what's really important is that you start experimenting on this website on your own when we're done. Afterwards, you can maybe go on this website and look at all of these different stuff that you can do. Maybe record some sound or again work on a kind of stuff. You can see more information about this on that. And we also have a small experiment from the app that we'll share with you.
But how, by the way, what do you mean by ultrasonic value?
Yes, that's a really nice question. So the ultrasonic sensor is a sensor that we use to measure a distance. And what it does is it produces a sound that we cannot hear. It's so highly pitched that our ears cannot understand it. Some dogs, for example, might be able to hear it, or some other animals. And also, these sensors are able to hear that. And it works on the principle that you may be accustomed to in your daily life. Uh, it basically works with echoes. When I, for example, shout in in a room that doesn't have much stuff in it, and if a wall is far enough away from me, then if I shout, I'll hear the echo of my own voice. What this sensor does is it produces a small sound that we cannot hear, but it itself can hear. And this sound goes and bounces off the nearest object. And by measuring how long it takes for that sound to go and come back, the sensor can actually measure the distance between the two objects. So by using that, you can maybe work on a lot of interesting experiments. And these sensors are used in lots of different stuff. For example, autonomous cars use a different type of sensor, but still use ones that work in a similar principle to measure the distance between it and other vehicles so that it doesn't collide with them and knows when to stop.
So it's like a sonar, and it's very similar to how dolphins and bats find their way.
Yes, exactly. It's inspired by the example of how to cheat. So maybe now that we've discussed that, we can go on and talk about the experiment that we'll do today.
Sure, so let's start with our materials. So you'll need a bowl of water and a few pinches of black pepper, and also a salt. And let me see if we can have the camera working. Meanwhile, Bahab, could you answer the last question we asked for the prize award?
Yes, so the most commonly used key when typing is the spacebar, and that's followed by the letter E, which is then followed by backspace. So if your answer was space, then you were right. It's the most commonly used one when we're typing. The letter E is the most commonly used letter in most languages, including English, but it changes from language to language. Some have the letter A as the most common language, whereas others might have other letters. And then the third most commonly used one is the backspace key, which is quite understandable because we all make mistakes and we sometimes prefer to delete that and replace it with something else. Uh, if you're interested in this and learning more about which letters are used in which languages, then maybe you can research what's called frequency analysis. These different languages have different letters with different frequencies attached to them. And by analyzing which letters are used in it, you can actually detect the language in which a text was written. So that might be a really fun thing to maybe research on your own if you're interested in codes and cryptology. So I can see that our experiment is ready. So let's move on to that.
So as I said, here I have a bowl of water and a few pinches of black pepper and some soap. You can also use acrylic paint or some oil instead of soap as well. So as you can see, the black pepper floats on water. They don't dissolve in it and they don't sink in it. That's because pepper is a hydrophobic material, meaning that water is not attracted to it. But why don't they sink? Well, how do you have any idea?
So that's really interesting because when I put salt in water, it quickly dissolves in it. Whereas when I put black pepper in it, it doesn't.
You're right. So that's because black pepper are hydrophobic, meaning that they're not attracted to.
Wow.
And other molecules like to stick together and form a surface tension. Because pepper flakes are too light and hydrophobic, they float on top and not sink. And now I'm going to apply some soap. So before I do that, I must wash my hands and make sure the soap comes bubbly. Are you ready?
Yes. Let's see what happens.
And now I'll dip my finger into this bowl.
Wow. So there's a hole where you dipped your finger. Wow.
Yes.
So when you were doing it before the soap, the black pepper went back to where it was, but now it stays away from the place that where it touched. Wow, that's so cool.
You're right. Soap is able to break down the surface tension of this water. And that's part of something what makes soap a good cleaner. As the soap moves into the water and the surface tension changes, the pepper no longer floats on the top, but the water molecules still want to keep the surface tension going. So they pull back away from the soap and carry the pepper along with them.
Wow, that's so cool. And when we're talking about this, I'll give a quick tip on how to wash your hands. So you may have heard that you need to wash your hands for at least 20 seconds and focus on every single part of your hand, including your thumb, your nails, and the part between your fingers. What's also really important is the bubbles. Soap is something that's mechanical, and to ensure that the soap is actually working properly, you need to see some bubbles. If there are no bubbles in your hands when you're washing, it means that you probably aren't rubbing your hands or you're not using enough soap. Okay, so I guess now is time to clean up after the experiment. And when you're doing this experiment at home, be careful not to spill all of these or you will have to clean them up. And so that was really interesting to see. And if you want to see this experiment and others like it, you can go on the Twing app and look at the experiments on there. And once you actually complete one of these experiments, what you can do is film yourself doing it and upload it on the platform. And you can also watch other people doing the experiments at home, be it the same experiments as the ones that you've done or totally new and interesting ones.
But let us explain this experiment. So can you please go back to the presentation?
Yes, of course.
This little demonstration of ours mimics how germs are removed from hands with soap. Since soap consists of molecules with a dual nature, just like the one you can see right now, these are water molecules. So as we said before, soap has dual nature. So this means one end of the molecule is able to attract water and the other end is able to attract fats and proteins. So let's say the coronavirus or the flu got you, and you have to wash your hands a few times a day, just like Baha said, and that's because the soap can both remove this from your hand as well as break down this viruses apart because of its dual nature. So even if the virus is not destroyed on the spot, the soap will remove the bacteria and viruses off the surface of the skin, and it will go down the drain. And this was the reason why we exhibited this experiment today.
So it can also mention that the soap can also break these viruses apart. There's a really interesting way to how this works. Most viruses have this outer layer that protects them from harm, and that's generally made by an oily fatty substance. It's called a lipid layer, and it's almost identical to what the types of oil and fat that you can find in your own house. And when you try to wash your hands when they're oily, you see that using water on its own isn't enough. Water doesn't dissolve oil. But when you use soap, you can actually dissolve the oil and remove it from your hands. So when you use soap to wash your hands, it breaks down this outer layer that these viruses might have, which exposes them and quickly kills them so that they cannot hurt you. So uh, now that we've explained all of this and shown you how to maybe work on this experiment and others like it at home, maybe we can look at a couple questions that you may have sent us. Let's see.
Here's a good one, Baha. What other experiments can we conduct with Twing?
Yes, the online app or it's the app. So we have lots of different and interesting experiments that you can find on the app and do at your own home. Akin, since you're currently working as a content developer for Twing, maybe you can share some of your favorite experiments with us.
So as you can see behind Baha, there are a few challenges that we chose for you. One of them is become a firefighter. So for example, in this one, you're going to learn acid and base reactions while making it more fun in a way that you pretend to be a firefighter. Instead of just blowing carbon dioxide all over the place, you're going to do it with baking soda and vinegar. So there are lots of many challenges like these and Twing, but let me announce the one we're going to let you win a prize for that. So to do so, as I said before, you should download the app Twing and then sign in and type protect yourself in search bar. This is the same experiment we did like 10 minutes ago, and you'll have to shoot or upload your own video, and the person who has the most likes will be awarded Twing coding set again.
Wow. So if I want to get more likes so that I can win this, maybe I can tell my friends to download the app and sign up so that they can like what I posted, right?
You're right, Baha, and as well as teachers might be helpful also because they can recommend new challenges for their students, and even parents where they can conduct these experiments together with their children.
Cool. So if you're at home, if you're bored, maybe you can download this app and sign up and upload your own experiments. And please talk to your other friends, recommend the app to them, or recommend this daily live stream that we'll have. and that will touch on different topics, different scientific topics, as well as new coding ideas every day.
So to wrap up, today we learned about inputs and outputs, the history of computers with Baha's introduction to binary system, as well as the story of Charles Babbage and Ada Lovelace, and made an experiment that showed us how soaps help us get rid of viruses and took a huge step on our science journey. We will be waiting for you same time tomorrow to catch up with Baha and his new topic, conditionals. Am I right?
Yes, and our daily topics can be changed by you. If there's some interesting stuff that you want to learn more about, maybe you can share that in the comments so that we'll read your feedback and maybe organize this curriculum so that it's more fun for you. So please write your feedback on the YouTube comments so that we can see what you want to learn more about and what you're interested in. See you tomorrow. Bye.